we're going to talk about a couple applications of the definite integral. First, a probability density function is a function that can be used to determine probability of an outcome X of an experiment. You're trying to figure out that the probability is within a certain interval. So such a function has these characteristics. One, the function must be greater than or equal to 0 for all x. The area under the graph of the function is always 1. And if CD is an interval, the probability that x falls between C and D is given by this definite integral, the integral of the function from C to D. So that's giving you that area, and that gives you the probability that x falls between C and D. Now this is a graph of the normal distribution. Let's say that this distribution was for students that were running miles, and let's say that the average time that it took for a student to run a mile was 6 minutes. So that would be the average, that would be at the center of this normal distribution. So let's say we wanted the probability that the student ran the mile between 5 and 8 minutes. Well, if this is 6 and this might be 5 and this would be 8 over here, the probability is given by the area under this function. So if we can calculate that area, which all we're going to do is integrate that probability density function, so the integral of that function between those two values, in this case we would go between 5 and 8, we would be able to find the probability that a student ran the mile between 5 and 8 minutes. Okay, so in this example, a certain city, the daily use of water in hundreds of gallons is a continuous random variable with a probability density function given by this function here. Now, if it's not here, the probability is going to be 0. So if x isn't positive, the function has a value of 0 for all negative x's. Find the probability that a household chosen at random will use between 300 and 600 gallons. Okay, so now we're told that this equation is giving us the water in hundreds of gallons. So if we want the probability that someone chosen at random is using between 300 and 600, our variable x is representing hundreds already. So we just want the probability that x is between 3 and 6, between 300 and 600 gallons. Now that probability, since this is a probability density function, will be 0.15 e to the minus 0.15x, and the intervals, the limits of integration, will be from 3 to 6. So that definite integral will tell us what that probability is. So now, to find this antiderivative, it's going to be of the form e to the u. We don't have a single x for the exponent right now, so we're going to have to do a u substitution. I'm going to let u be my exponent of the e function, the exponential function. So u is going to be the negative 0.15x. The du then is going to be minus 0.15 dx. So notice that I've got my, if I rearrange this, I've got my 0.15 here with my dx. So all I'm missing is a negative sign here, and then I'll have a minus 1 out here to make sure I haven't changed my problem. And so this part with this becomes my du. And so my problem when I make my change of variables then is going to be a negative 1 on the outside. We're going to have e to the u power du. And now I can go ahead and change my limits. Right now these are x values. X is 3 and x is 6. So if x is 3, the u is going to be minus 0.45x, or minus 0.45. And if the x is 6, the u is going to be minus 0.9. Now you don't have to switch those. You can just not worry about them until you switch the antiderivative back to x variables and just use the 3 and the 6. So I'm going to go ahead and use these new ones. So from negative 0.45 to negative 0.9. So now this antiderivative of e to the u is just e to the u. So I'm going to have minus e to the u, and I'm going to evaluate it for these new values, negative 0.45 to negative 0.9. So put in the negative 0.9 first, so we have minus e to the minus 0.9, and then minus what we get when we plug in the minus 0.45, so it's going to be a negative e to the minus 0.45. And we'll need a calculator to figure out what that is. So we're going to have the exponential function, a negative, so I'm going to need to use my minus sign, minus the exponential functions under the natural log, so second e to the x, and then I need the negative 0.9, and I need to close my parentheses, and then I'm going to have a plus the e again, and now negative 0.45. Close my parentheses, I get approximately 0.23. Now, probability is always a number between 0 and 1. Probability of 0 means it can't ever happen. Probability of 1 means it always will happen. So that would be our probability that a household chosen at random uses between 300 and 600 gallons of water. Now, one thing to point out here, if you're looking for the probability that a certain household uses exactly 300 gallons, that would be the integral from 3 to 3. So that would be saying that x is between 300 and 300 gallons. Now, you're talking about an area, and if you've got an area and you've just got one value here of 3, there's not going to be much of an area if that doesn't have any width there. So the probability that it's exactly a certain number is actually 0. So keep that in mind when you're dealing with probability density functions.